So I'm going to be over here. Hi, everybody. So my name is Debbie Walsh, and I teach in Westfield at Roosevelt Intermediate School. If you click on this QR code, which is the same as the QR code that's on the papers in the back of the room, this will take you to a folder with all of the things that I'm going to talk about and share. So all the files that I am going to open, including these slides, are in that folder. And the presentation, we did this last year at this convention, and the video from that is in there. And my department chair is filming it, so I'll put that in there too, or a link to that. Or I'll put, if it ends up being on YouTube, a link to it in the slides so that you can go back and look at it or share if you find it useful for you. So to begin with, I've been teaching Open Science since 2018, and I've taught all 3 grade levels. I started out in 6th grade. Then I was a leave replacement for the first 3 years I was in Westfield, so I kept changing what grade level I was at. So I've actually done all the grade levels. And then I landed in 8th grade, and I've been teaching 8th grade for the last 5 years, predominantly, except for one section of 6th grade that I had sometime in the last 5 years. That I don't remember when it was. So I've done a lot of the units. And one of the things that is really hard to see when you are zoned in and just trying to like stay afloat and not get drowned in the Open Scied wealth of materials is how interconnected all the units are and how beautifully they actually work together when you can see them from Unit 1 as the first unit of 6th grade to 8.6, the 18th unit as they go through. And as an 8th grade teacher, I can tell you with certainty that it really does all come together in 8th grade if you do the units, all of them, and in order. That being said, when we started doing Open Sci Ed, we were a pilot school. So as a pilot school, the units were not all flushed out. So currently, if I look at the genetics unit, which is 8.5, there are, trying to look at how many lessons there are. Actually, I just look right here, because I have it here. There are 17 lessons, right? 17 lessons. The pilot did not have 17 lessons. It only had about 2/3 of them. And so one thing that I would recommend to most people that are diving into this for the first time is to do 2/3 of the unit, because that's where the meat and potatoes of everything is. That last third of the unit is usually some kind of application, right? It's usually some kind of, now look at this. And so for the genetics unit, it was all about plants. So the end of the unit that we didn't have when we did it as a pilot district was all about flowering plants, asexually reproducing organisms. There was a little bit about the asexually reproducing organisms, but the whole plants and flower dissection and all, that wasn't there. It showed up when the formal unit came out a few years later. And my point is, a lot of you are diving in to these 18 units that are all flushed out, which it's not possible to teach 6 units in a year with all this level of detail the first time through, because you don't know what you need to do and what you don't need to do. So what I aim to do today is to try to give you some strategies to make it doable, to make it a little easier, and to make it not only easier for you, but easier for your students to understand better. I assume, but I put it in here anyway, that all of you have access to the Open Sci materials. This morning, my colleagues did another presentation at 10 o'clock. And there, someone came by who couldn't come to their presentation, was saying, where are the assessments? And I was like, oh my God, like, it's true. There's so much in here. It's very hard to go through and see what's what, but the assessments are embedded in the lessons. So the way Open Sci Ed usually works is, let's say you've got a unit that has 14 lessons. You might have lessons 1 to 5, and then lesson 6 is an assessment. So you wouldn't know to look in lesson 6 for the assessment unless you realized that that's where the assessment was. And then you might have 7, 8, 9, 10, and 11 is another assessment. And then you'd have 12, 13, 14, and 14 will have some culminating activity, not necessarily an assessment. But that's the way the program works, and that's true of all 18 units. So when you go and you click on Open Sci Ed and you make a password, you have access to all the materials. And in those materials is embedded all of the assessments. Now, in Westfield, we have had a lot of practice doing this because, as I said, we've been doing it for so long. All of the units, whether you're doing a high school unit, you're doing a middle school unit, I assume, Tom, you could answer, are the elementary ones following the same format as this, essentially? So even in the elementary units, they all follow the same format. There's some kind of anchoring phenomenon. You get the kids excited about it. They come up with some questions. It sounds crazy that they're going to come up with the right questions, but it's like magic. They always come up with the right questions. Every 100% of the time, the kids have come up with the right questions on the question board where you can steer them down the path to find the answer to this phenomenon. We figure out, well, what kind of experiment do we want to do? They always come up with the experiment. It's very refreshing to see, but it really, they always come up with the right experiment. We get some data, we have a discussion about what we found out, and essentially we repeat the process throughout the unit until we get to the end. So that process of asking questions, finding the answer to those questions, generating more questions, doing another experiment is what OpenScience is all about. So it's all about having data, it's all about the kids thinking and processing, it's all about them figuring it out for themselves. What makes us very different from every other way I've taught for 19 years, I taught high school chemistry for 9. There isn't a textbook, which for some people that's a really hard thing to get over. It's not learning concepts and facts and then applying it somewhere. It's learning concepts and facts in trying to figure out what's going on. So in 6th grade, the first unit is a light unit where they are encountering a one-way mirror and they have to figure out how a one-way mirror works, which is kind of cool. They're all like, I wonder how that works, right? They know how a mirror works, they know how a window works, but a one-way mirror kind of does both things, and it's a little confusing and exciting and everything else like that. In 7th grade, they start with a bath bomb. So how does a bath bomb work? Where do the bubbles come from? What's going on there? And so the kids naturally come up with questions about, is it something new? Is it just air trapped in there? And it leads to experiments to figure that out. In 8th grade, the first unit is about contact forces, and the phenomenon is a broken cell phone. So like, how do you protect things? Why do sometimes they break and sometimes they don't? What's true about those materials? And that's the whole push for that unit. So all 3 units, well, all 18, start with a phenomenon. This is the place where you want to spend the time and you really want to get them excited. And I don't know about, how many of you are actively teaching OpenScience? So like everybody here? Okay, so almost everybody here is actively teaching OpenScience. You probably know what it's like to be about halfway through the unit and then they lose interest, right? And you lose interest and they lose interest and everybody's bored with the unit. No matter what happens, you can't do that. You have to pretend. You put on your like little happy hat and this is the greatest unit of all time. And the reason I tell you that is because the second that you're bored and you show them that you're bored, they will never come back from it. They're just going to be done. So you have to find some redeeming value or like tie up your ends and move on. So like either choice is fine, but you don't want to stay in that lesson and you're bored and they're bored. You need to kind of figure it out. So why do we want to spend a long time in lesson 1? It's the beginning of every unit. It's what shows them the phenomenon. Is it possible that you go into the first day with the phenomenon and a kid raises his hand and says, well, Mrs. Walsh, I know that a one-way mirror works because the silver layer that's on there is not very thick, and so some of the light goes through and some of it reflects off. And then you go, thanks for that. Now, when that happens, I try to cut them off at the start. When I say, oh, I'm glad you know how it works. Why don't you hold that thought for a moment, and as we go through, see if you were right. Or I ask them to write it down. Write down how you think it works and give it to me, but don't tell the whole class today, right? But sometimes you don't get to do that and the answer's out there. But what's special about OpenScience, it's about how do you know that's the answer? So even if they know that what the answer is, they know that McKenna has celiac disease, they know that the bath bomb is citric acid and baking soda making the bubbles. How do you know that? And they can't answer that question. So it forces them to do an experiment to prove what they already know and to get through it. So you can still like keep them there and keep them excited about it. They're gonna be fueled by your excitement in the unit. When we go through lesson 1, the initial model is super important. Everybody, I'm on the Facebook groups too. Everybody gets so upset and bent out of shape in September when they're on the Facebook groups. What about the initial model? How do I know? Like, it doesn't matter what's in their initial model. It's just what they're thinking. So they can't be wrong on an initial model. Like, that's the beauty. Do you think that there's air pockets in the bath bomb? Great. Do you think that there's some magic going on? Great. Do you think that, in the cows unit, it's all about the cow's DNA and that the cows have this special gene that's making their muscles grow out of control? Do you think that the cows are eating extra protein and working out? Great. It doesn't matter because their initial model is just what they're thinking right then and there. These other things, related phenomenon, the consensus model, the driving question board, every time they end up going where they're supposed to, and we end up in a place where the kids can start learning and figuring it out. I mentioned before, it's all about phenomenon, and there's all different ones. These are some from various units. This is the bath bomb. This is the MRE, where they learn some more. There's a lot of chemistry in the 7th grade units. So this one, they learn about chemical reactions that generate heat. The bath bomb is about new materials being created. The cups unit is about thermal energy and how to keep cold things cold and hot things hot. The orangutan unit has to do with food webs and like their home is being chopped down and what that does to the number of organisms that live there. And I think this is from the Hale unit, which is another 6th grade unit. Actually, the Hale unit is one of my favorite units because the kids don't have any idea why it hails. And it's a really cool unit. My favorite unit of all of them, for the fact that the kids don't know the answer, is the magnetism unit. And you might say, oh no, the kids know about magnets. They do. But the phenomenon for the forces at a distance unit is a speaker. And very few people know how a speaker works. I didn't know how a speaker works. And so when I was going through the first time and I learned that it's got a regular magnet and an electromagnet that interact, blew my mind, and it blows the kids' mind because they have no idea. And when they take a speaker apart and find a magnet in there, a lot of them are very surprised. There's a magnet? What's a magnet? Oh, and then we learn about magnets. And anyway, it's a really cool unit. This is our giant cow who, anyway. So I teach mostly 8th graders. As I mentioned, we have contact forces, sound, forces at a distance is magnetism, earth and space. This one is also pretty amazing because the kids don't understand why seasons happen. They don't know why it's warm in September and it's cold in March. They don't know why the sun moves and comes lower or higher in the sky. And when they finish the earth and space unit, they understand all of those things and they feel like smart people. They feel like this is something a normal person should know, and they don't know it going in and they do know it coming out. So, the units are really very, very beautiful. And when you can see them as 8th graders, after doing all these other units, you really see all the pieces come together. But it takes about 5 years. It takes at least 2 or 3 to kind of get your feet wet and to know what's going on and to know how the pieces come together. Unfortunately for the 6th grade teachers, you never get those experienced kids coming through because that's the first year. But the 6th grade units are paced very slow, where the 8th grade units are paced very fast. So one thing that you should know, if you're putting the units out of sequence and you're doing an 8th grade unit in a 6th grade, you are going to find the pacing very fast. Where if you take a 6th grade unit and you put it in the 8th grade, you're going to find that you're going through it way faster because you don't have to teach them all the routines. And they built that in for the 6th grade units. So you should be aware when you put them out of sequence, I guess maybe, I don't know what your opinion would be, but like 7th and 8th grade, it's still pretty fast paced, right? So if you do a 7th grade and an 8th grade and you switch them, it's less of a big deal than the 6th grade. 6th grade is really very slowly paced. That being said, few things. Why don't they Google the answer? I tell them don't Google the answer. I tell them it's going to ruin it, right? If you Google bath bombs and you find out what the ingredients are in a bath bomb and you come into class the next day and you're like, I know what it is, I Googled it. Okay, waha, wonderful. Like, now class is going to be boring for you, right? So on the first day of 6th grade, I told them, you're going to be doing this for the next 3 years. Don't Google the answer, right? Can you Google how a one-way mirror works? Yeah, but we're going to know in about 3 weeks. So just hold fast. You're going to know, you're going to learn. And they're excited to learn about what it was. They were all like surprised when they learned last week about what actually makes a one-way mirror work. You need to stress to them that they have to know why, not just what. And so Open SciEd really focuses on the how to learn, how to analyze data. It gives them very good data analysis skills. Somebody mentioned in the earlier presentation about taking standardized tests, taking the state tests. The NJSLA in science is a lot of like chart reading. It's a lot of graphing. They have to analyze. They have to look at data and figure out what's going on. This curriculum shows them how to do that. Because they're looking at data and trying to answer a question, they're motivated to figure out what the data means. They really do get the process of thinking, working independently, working with a group. A lot of the open science stuff has them divide and conquer. So I'm going to look at this, you're going to look at that, you're going to look at this, you're going to look at that. We're going to bring it all back together. I find that to be very useful too. It keeps everybody accountable, everybody's learning from each other, and it really works very well. So your enthusiasm, as I mentioned before, is really the most important thing to keep things flowing. If you're bored, they're going to be bored. Like it's what it is. So if you really don't enjoy a unit, find a way to make it more interesting for you. Find a way to get through it. Maybe something that they're doing as a lab, you hate that lab. Maybe you record the lab with one of your colleagues and you just show them in a video, right? You don't have to do every single lab in person. You can give them data, and there's a lot of different ways that you can do this. So the storyline, I'm gonna like back up a little bit. So I have some storylines. I might even have enough to give everybody one. Look at that. So this is a storyline from an 8th grade unit. I'm not giving you one. I do have enough for everybody. Wow, shocker. See, it pays to not be at a crowded workshop. So the storyline that I'm giving you is from 8.5, which is the genetics unit. So the picture on the front is the giant cow. And this is what you have for every open SciEd unit, whether you're talking about an elementary unit or you're talking about a high school unit. Got to make sure that I have enough time to go to my slides because that's what this is about. In here, you can see the last column or the last 2 columns. What do we do and figure out, and how do we represent it? So if there's a drawing to go along with whatever it is that you're learning in that lesson, it'll be here. But the what do we figure out is something that you should have a running idea in your head of how the unit is going to progress. So this whole thing is, how many pages? 9 pages, okay? So 9 pages of reading to keep yourself in the loop of where you're trying to go is super important. If you're on lesson 3 and you don't know what they're learning in lesson 5, then you might mess it all up for yourself by either revealing something that's going to be revealed later to them or missing something that's critical that they have to know in order to be successful in lesson 5. So it's important as you go through to kind of know what's expected. And in the materials, so the materials are all digital, but in the actual materials, if you look at any one lesson, so here I'm going to look at lesson 5, and in the beginning, in lesson 5, there is a page right after like this introductory part where you have lesson 5 and they tell you what you're going to do. By the way, this here, what students will figure out, this is what I use as my progress tracker key. So I start every unit, especially when I'm doing something brand new, by going through all the materials and making a progress tracker key. Why do I make a progress tracker key? Because then I want to know what I'm supposed to accomplish in every one of those lessons so that if I miss something, at least I know I missed it. So on the first page of the lesson, when you're in the full guide, not this little one, has what the students will figure out. So I make the key out of that, and then when I'm about to do a lesson, I always read this page, which is right after the little summary, which says where we are going and where we are not going. And the reason those are key is because sometimes where we are not going might be something that seems like we should be going, but it's not something we're going to do here. So for example, in genetics, we don't do dominant and recessive. That doesn't even come up in this whole unit anywhere. So it will mention that. We are not talking about dominant and recessive in here. We're talking about what genes do, that they code for proteins, they code for proteins that do this, and the whole dominant recessive thing isn't really mentioned at all. We added that in, patterns of dominance, as something, and you'll be able to see that in my slides. But that's something that Open SciEd does not include in their curriculum. But you would know that by reading this first page. when you are teaching Open Sci-Ed, you have to do the labs ahead of time. You have to check the materials ahead of time. If you're like, oh, we're going to do the materials lab tomorrow, great. And you come in and you have styrofoam and you have cotton balls and you have all the things you need to do your thing, and you're all set up and you've got your carts and you got your spring scales and you got your tracks, and I'm ready to go, but I didn't practice it, right? But I'm going to go, I'm going to do this, and you put it there, and now the two spring scales go and they miss each other every time. Now you've just wasted all of their time. You wasted all of your time. They learned nothing from it at all. And I have never, in 8 years, gotten that lab to work properly. Never. So what do we do for that lab? We give them data. We give them data that is correct. I had kids, after we did that lab, tell me, wow, I'm surprised. Metal is a really good protector. Oh my God, no, it's not, right? That's terrible, but that's what their results said. The force went down for the metal and it went up for the bubble wrap. Like, I can't have kids leaving my classroom saying that to people, right? So we give them data, and the data is correct. They can analyze the data. Then they can look at the close-up pictures of metal and cardboard and cotton and all that, and they see it's full of holes, they know it's squishy, and they come up with the right conclusion. Well, why did that happen? Because we did the lab ahead of time. We checked the materials ahead of time. We knew it was terrible. And no matter how many times we tried to do it, we couldn't get it to be successful. So we do it differently, right? And that's what your role as an educator is. A lot of people walk in and they want Open Sci-Ed to just be like magic. They want to be able to open the book and say, okay, on day one, I'm going to say this. I'm going to say, what were some of the ideas that you and your partner shared about why some baby cattle are born with big muscles and others aren't? Like, you can't do that without going through it yourself. Like, we're still teachers, right? So you still have to prepare. And that's where the other 8th grade teacher and myself have kind of taken this to the next level. So I want to, I think, skip out of this. Okay, you have to figure out what works for you and what is going on. So a couple of things that we do. We do constant check-ins. So every week or every 2 lessons generally, we do a check-in. It's a Google form. It's all multiple choice. Did you get it or not, right? And it really helps me know where I'm at, right? And if there's 2 kids in the classroom that keep getting a 3 out of 10, then I know that those are kids I need to pull aside. Those are kids I need to talk to. I need to do something with them. So constant check-in, I would say, is a very good idea. Even if it's a Post-it at the end of class, you hand out Post-it notes and you say, what was one thing you learned from today? And you have a student who can't say anything, like, you know there's something going on there. But I like it to be a question they have to answer, even if it's just a multiple choice question, because that'll give me a better idea if they understand what we're talking about or not. A do now, if I don't do a question at the end of the class, I try to do a do now in the morning. So now what do I do to enhance my slides, to catch the kids that were absent, to catch our students who need a review? Also, my slides can be considered copies of notes for my students that need copies of notes. I post them to everybody in Google Classroom. So every day, we're doing a new lesson, I have lesson 3 materials. I'll post my lesson 3 slides. I'll post all the worksheets that we're going to do. And if a student is home, they could print out that worksheet and follow along, because I add things to my slides. I insert the questions and answers from the teacher resource. So I go in here and the prompt, suggested prompt, say this, I put it in my slide. And I also put answers in the slide on the next page, so that, like, I'll say to the kids, okay, blah, 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 and they give me their answers, and then I go to the next slide, boom, look, you had all the same answers that I was expecting you to say, right? But the kid who's home can also see those answers. I put the vocab in. I put summary slides at the end of the lesson. And at the beginning, I try to put either a check-in question or something at the end. To make grading easier, I use rubrics, and I'm going to show you what those are as well. They're like little check boxes that make things a little easier. So I have slides that I made versus slides that Open Sci-Ed has. So these are the standard Open Sci-Ed slides. Can you guys all see that from where you are? Do I have to make it a little bigger? Yeah. Make it a little bigger? So let's see if I go. I don't know how much bigger I can make it, actually. That's probably as big as I can go. Oh, sorry, guys. That's about as big as I can go. But We'll try. So on the left is the standard materials from OpenSciEd, and on the right is what I do. So you can see the OpenSciEd slides. We have make a T-chart, slide B, notice and wonder. We have share with a partner. What did you notice and wonder about these two cows? This is 8.5, by the way. And then we have a whole class discussion of what did you notice. What we do instead is we have a slide that, actually I'm going to do this just, we have a slide that has everything we're going to do today. So in that slide, we have our objectives, which I get right from the materials from OpenSciEd. We have our homework. We have what the agenda is for today. And we have our do now. And we add usually some little silly slide just to get them walking in the door and being entertained by what we're going on. We have what we're going to do on our first page, set up our notebook, right? This isn't in the OpenSciEd slides. They tell you set up your notebook, but they don't have a slide telling you to set up your notebook. So I add this. It's our muscles unit. What are your initial thoughts? Oops, I think I skipped one. We need to set up our personal glossary page. Then we're going to set up lesson 1 where we're going to notice and wonder about our cows. Now finally, we get to our notice and wonder chart, which was OpenSciEd's first slide, right? This was taken from their stuff. You'll notice this is the same as their slide. So I use their slides. I just add slides before and after so that all the stuff is in there. So I don't have to like remember what I wanted to do, right? The other thing that I do, just like I did here, is I print out my slides and I write myself little notes on my slides, and then I have this to look at so I don't have to remember what the next slide is, because that's not going to happen. And it keeps me knowing what's going on. So again, we had write down what you notice and wonder. Then we talked with our class. So this slide also was an OpenSciEd. Observing more animals. We had dogs, and fish, and mice, and rabbits, and pigs. And we had to look for patterns. We had a worksheet that we made where they had to record their initial thoughts. If I go back to the OpenSciEd slides, you can see over here, if we go big, we had the same slides again. We have other animals, dog, fish, mouse, rabbit, cattle, and their worksheet. So notice their worksheet versus my worksheet. Very similar. Little bit of formatting to make it a little more something that I'm doing, but we didn't recreate the wheel. This is the same slide that they used. We changed the color a little bit. We changed the background. You can do that by changing the theme of your slide and import a different theme, and then you have it. I'm not the best at doing that, but one of the other 8th grade teachers is. So they found like a genetic little like DNA swirl for the background of the slides, and so we use that. But by doing this, you end up having something the kids can go back on and look at, right? And this is lesson 1. If I keep scrolling, I have it for a 6th grade. So here's, oh no, I did it for the 8.3, which is the magnets unit that I told you I love so much. So same thing here. We look at the slideshow here. This is what OpenSciEd sends you. So they're not sending you nothing. Like OpenSciEd slides are good. And for the 6th graders that I'm currently teaching, like they use the OpenSciEd slides the way they are. So like I have to add to them if I want them to look like my 8th grade slides. So the OpenSciEd standard materials are not awful. As you can see here, we set up our notebook, right? They're telling you what to do. This is right from OpenSciEd, definitions in there, telling you what to do with your filings, drawing what you see, what is our evidence, right? What did we figure out? Our driving question board, let's go back and see where we have to go, with some directions with magnets. These are all OpenSciEd slides. So you might say, oh, they're not bad, and they're not. But in our slides, again, we add in answer keys. We have a day 1 slide so we know what we're going to do. This was our progress tracker from the lesson prior that we put in here so that the kids have it to review. We'll talk about it and they can come back and look at it. In here, we added some big ideas that weren't in the OpenSciEd slides. Then we get back to where we want to go from here. This is an OpenSciEd slide. We did the same thing they did before, but we have answer keys. I put in a picture of the setup. I put in what our thing actually looked like when we did the lab so that the kids that aren't there, or just someone who doesn't remember or drew a crummy picture, has something to look back and look at. Okay? What did we figure out about the magnetic field? Day 2, Iron Man. And we have, there's an answer key one in this one as well. So you can see the picture of what we did. So just adding those little things in makes it notes instead of just fill in the blank where it doesn't have any actual information in there. I also post a progress tracker key. Let me get out of this one. I feel like I'm running out of time, but I don't think I am. Okay. I also post a progress tracker key. I'm just gonna move that. I'm gonna move this so I can show you what I'm talking about. So actually, I'm gonna show you a rubric that makes things easier to grade a little bit, and then I'm gonna show you an assessment as well. So this would be one of the labs that we do. This is the deformation lab. So this is in our Unit 1 contact forces. Lesson 3 is about deformation and how objects bend when you push on them. And at this point, they don't know that all objects bend, nor do they know that all objects bend with any kind of force. So all they know is that when they push on something that's soft, it bends at this point. And so in this lab, according to OpenSciEd, we come up with our independent and dependent variables. We talk about it a little bit. And then we test various thicknesses of different materials. And according to OpenSciEd, everybody does a different material and a different thickness. So the suggested materials are styrofoam, cardboard, coffee stirrers, things like that, that you could suspend between 2 bricks and you push on it with a spring scale and it should bend elastically. Styrofoam does not bend well. They also say rice noodles. Rice noodles snap very quickly. Styrofoam kind of gets wrecked. Cardboard kind of bends as soon as you start to push on it. But coffee stirrers do an excellent job with this. So what we tend to do is we show a demonstration of rice noodles so the kids can watch what happens to the rice noodles when they break very easily. And I don't know if I have the link in here. I don't have the link in here. It's okay. And then for this, they use either 1, 2, or 3 coffee stirrers. So there's 6 groups in the classroom. There's a group that 2 different groups do 1, 2 groups do 2, 2 groups do 3. And what's kind of nice about it is they see that as you add thickness, as you have more coffee stirrers, they don't bend as much, so they're stiffer, and it takes more force for them to bend. So they get that. That's the big idea from the lab that they're intended to get from OpenSciEd. But when they do styrofoam, when they do cardboard, when they do rice noodles, they don't get the same output. They don't get like what it's actually about. So the coffee stirrers work really well, and it leads to the ability to make a graph, and they draw a best fit line, which is their first experience drawing a best fit line in this unit in the beginning of 8th grade. So that's nice too, because you can talk about how to do a best fit line. It's not gonna be connect the dots. They don't all hit the line because it's data. And so it's a nice experience. You can even work with the math department and have them graph it in math class if they're all in the same math class, which they're not in our district, so I do it with them. So you might look at this and say, oh my gosh, how do you grade that? That's a nightmare. And it is. So what we do is I made a little rubric. And so this is my favorite thing that I ever did. And I don't even know why I did it, but it was fantastic. And what I do is I print out 25 of these, and then I cut them up. And so this is what the child gets stapled on their lab. So when I'm looking at their lab, if they wrote reasonable answer to a description of the rice demo, and they wrote about what variable goes where for independent, dependent variables, they get 2 points. Their data table is complete and accurate. Their graph has a title, axis labeled correctly, data plotted correctly in a best fit line. Their questions are complete, and there's evidence, and it's appropriate. They get all those points, and it makes it very easy to grade. The other problem that I had with OpenSciEd, when there's so much open-ended stuff, I'm writing the same thing every paper. I'm writing, you didn't use complete sentences. You didn't use complete sentences. Now I just have to circle it and write 1, and I don't have to write that word every time. So it kind of cleaned up my grading process. So I try to do this every time there's an an activity that's like that, that has the same mistakes they're going to make again and again, and it's very open-ended. So I try to do this a lot. My 7th grade colleagues jumped on the bandwagon. So now I don't even have to explain while I'm doing it. The kids are like, oh, there's a rubric right there. So it made everything much, much easier. It's check boxes. You staple it onto their paper and write the score on the top, and they get some feedback that way. So what do I do when students are absent, when students need to review, when students need to do all these other things? I refer them to the slides. They're there, and like I said, I post them every day, and they have everything in it. Now, I know you can't just make slides. It's not like it takes a day to, just, I'm just gonna throw them in and I'll do it during a prep period and I'll be all set. It takes a couple of hours to do that. But the first year we were doing this, we were only introducing one new unit kind of every 6 months because we were a pilot district. So it made this whole process a lot easier. So I don't want to say like there's a magic wand that will make slides that look like this immediately. There were 3 of us teaching 8th grade. So we would alternate every 3rd lesson. We would do this. So if I were doing this for lesson 1, another teacher was doing this for lesson 2, and a 3rd teacher was doing it for lesson 3, and then I knew I had to do this for lesson 4. So when you're doing that, it's a lot more palatable, right? If you have other people that you can work with. Currently, I'm teaching 6th grade, and so we don't have this, and the other teachers that I'm working with don't use slides in the same way that I like to use the slides. So I'm taking Open Science slides, and I'm adding in that first slide that has like the objective and the homework and that kind of thing on it. But I don't have all these question and answer slides built in, and so I'm kind of doing that as I go. So it's a lot of work. But if you have colleagues that are working with you, or even if you have a co-teacher in the room that can insert a slide with like the class notes, you can do it that way too. The other thing that I want to mention that the other 6th grade teachers do, I'm going to come back to my pitfall, is they add in, nope, that's not it. They add in a notes, and I know 7th grade does this too, because that's why I got excited when I saw this in there. But for every lesson, they have a class notes. And the class notes, this is blank at the beginning. So when they post, or when I posted this, I can give myself credit. When I posted this, it was blank. So I posted the slides, I posted whatever worksheets we're doing, and I posted this blank class notes paper so the kids could see it if they wanted to. And then on day 1 of lesson 2, we observed the one-way mirror in the classroom. So we picked up the one-way mirror and we were able to look at it and hold it up and flash a flashlight on it. And the kids wrote down on their paper what they noticed and wondered. And then we shared. And as they shared, I typed into this doc. So they shared with me, it's like a mirror and a window at the same time. It's flimsy. On the black tray, it looked like a mirror. Tilting it changed what we saw. They wondered, why can't we see both people? What would it look like if we turned off the lights? What happens if we hold it up to a window? These were the things the 6th graders told me. And then we went from there, and we switched the light in the light box. So if you're not familiar with this, you take 2 copy paper boxes, and you have a one-way mirror in the middle, and you put a flashlight on one side. And in our boxes, we use Forky and Spoonie. And I like using Forky and Spoonie because Forky has prongs and a spoon doesn't. So you can tell which side of the light box you're looking at. You could tell if you're looking at the student or if you're looking at the teacher, because the student is a fork and the teacher is a spoon and he has googly eyes. So it's a fork with googly eyes and 2 spoons with googly eyes are the teachers and the things. So when we did it the first time, the light is on for the student's side, and the Forky sees himself when you look from that side, and when you look from the student side, the teacher side, you can see Forky through the other side. And so we switch the light. And when you switch the light, the whole phenomenon reverses so that the spoons see themselves and the fork can see the teacher. So they were very excited to report that to me. Forky could see the spoons, the teacher could see themselves. What would happen if both lights were on? What would happen if both lights were off? Well, surprise, surprise, this is the beauty of Open Science. This is the next experiment we did. So, right, like it's like they can read their minds. This is what all the kids wanted to know. guess what? That's the next experiment that they recommend. And so for that one, we did the same thing, both lights on, both lights off. They told me what we found. I typed it into our document, and then this is a notes sheet that the kids who need copies of notes, you could print this out and you could hand it to them if they're gonna, like they want copies of notes to send home, but it's in Google Classroom. So it's there for anybody to see, everybody in the class to see. The kids get really excited. Like, and again, it's very much, they are saying what to do, and then it happens. Here we learned about sharing data. So only half the class did the lights on, and the other class did the lights off. So they only got to see half of the experiment. But then they had to go find a friend who did the other experiment and talk about what they saw. And it's really neat to watch them do that. We did an ed puzzle. They had to answer some questions about path of light. We did the Walt Disney World article, which again is an Open Scied thing. There's a Walt Disney World article about glare. And then there was kind of some stuff about angles of light and how it refracts and how it reflects and it transmits and all kinds of stuff. This was a kind of thick lesson, as you can tell. There was a lot of stuff, path of light. Oops, I didn't finish our notes. Bad me. But my point is that having something like this is helpful too, right? And this you can make when you're looking through the lesson and you're trying to figure out what's going on. So if I get back to here, okay? When you're talking about Open Scied and you want to make the most of it, the number one thing that you need to do is to read ahead. You have to know what's coming. You have to know like what your intentions are. You have to know the goals. If you don't know that, like you're going blind into the program, you're really going to struggle because you're going to be stressed out. You're going to be a little confused, and it just makes everything harder. Skip things they already know. If you think they already know what this lesson is about, or you think this lesson is useless. So there are some lessons that the lesson is to find out that that was a bad lesson. For example, if you're doing any 8th grade, in the Contact Forces unit, there is a lab in lesson 2 where we drop things and try to break things. Okay, that's the lab. And so the lesson from the lab is that that was a terrible lab. Like that's the lesson. There was no directions, there was no control. You're trying to drop, you're trying to drop a baseball onto a cracker and you keep missing and there's nothing consistent about it. How could we measure damage? I don't know, there was no way to measure damage. That's the point of the lab. So do we have to do that lab? No, it was kind of fun to break things. Like they enjoyed it, it was good, but they have all kinds of directions in here about making sugar glass. Are you kidding me? If I made sugar glass and then I told the kids to bring in baseballs and tennis balls and drop it on the sugar glass, what is my class, my class would be full of ants by the end of the week. So no, we don't use sugar glass. No. What do we use? A few years ago, we had some severe allergies in the classroom. And so we didn't even want to use crackers, right? We were using crackers and that kind of thing, but we didn't even want to do that because we didn't want that dust all over the room. So we told kids to bring in things that weren't edible and that wouldn't shatter when they broke, right? So we didn't want anything glass or this kind of thing. So what did kids bring in? They brought in a tissue box and we dropped these balls and tennis balls on a tissue box. Awesome, it's to teach you that this is a bad lab. So it didn't matter what they brought, right? They could bring in they made Lego structures. They brought in their Lego structures and they're dropping a tennis ball on it and Legos going everywhere. Okay, great. Like, what did we learn from that? Nothing. This is a terrible lab. Yes, it is. Okay. And then we move on from there. And the next lab that we do is the bending lab where we bend the coffee stirrers, which is a very good lab. And they learn a lot from that. They do a graph and everything else. But could you skip the lesson 2 lab? 100%. Like people that are on Facebook talking about making sugar glass. How am I making the sugar glass? I'm like, don't make the sugar glass. Skip it. Like there's no need to do that. And if you really wanted to show them the sugar glass lab, do it at home in your kitchen, all controlled, and show them drop a baseball on the sugar glass, drop a tennis ball, it's terrible. It's very hard. You're going to miss. It's not a good lab. But you have to read ahead to know that. If you didn't know that there's no point in that lab, you just spent 3 days frustrated making sugar glass, and then you go in and now your room's a mess, you got sticky everywhere, and you didn't have to do it because it was to learn what not to do, right? That's the point of that lab. If your students are doing this for the first time and you're teaching 8th grade, they might be missing stuff. There might be things that they're expected to know. And so when you read that page that says, where are we going and where are we not going, you might find out that, oh, they are supposed to have learned about heat transfer in the cups unit in 6th grade. And you're in 8th grade, and we're talking about friction, and they've never talked about heat before. So they don't understand what they don't understand. So you might have to back up a little bit and talk about how kinetic energy causes molecules to move faster, right? That the faster they move, the warmer they get, and the more kinetic energy they have. That might be something you have to review. But you only know that if you've checked it out, right? And you know what they're learning in the other grades as well, which is something that's hard to do. You need to keep things moving. You need to always do the lab ahead to make sure that it works. And if it doesn't work, then don't do it, right? Don't cause them to be confused. You can always give them data. You could always do it as a demo and record yourself doing the lab and show them a video of the lab. I feel like there's a lot of labs in some of these open-sided units. And instead of doing 12 labs where 5 of them don't work, or they don't work well, or they're just difficult to set up, then why not do 4 labs perfectly and let the kids have the full experience and the rest of them do it another way, right? And you'll still get the lab experience, but you'll get them moving a little quicker and maybe giving yourself peace of mind. You also have to be forgiving of yourself. You're not going to be able to do everything. It's not possible. It's really not possible to do everything. You have to know like what you can accomplish, and you have to know your students. So if you have a year where your students are particularly weak in one area, then you might have to tone everything back. And as long as you know what those big ideas are you're aiming for at the end of the unit, and you hit them, it doesn't matter how you hit them, right? So you want to do it as much as you can with this method, but sometimes that's not possible. And you have to be able to like tell yourself that. You have to keep things moving along. If you get stagnant, like pick it up one way or another. Maybe you're gonna take a day and you're gonna do something that's related, but is not what you're doing because you've all had enough of it and you need a little break. Stay excited yourself about the learning that will come, and know that like by year 2 or 3, you're gonna be shocked at how different it is, how it all just gets better. Because every year that you do this, you know better what they know. You know better what like they don't know. You know what you can go through quicker. You know what you can't. And I can tell you too that you kind of learn this hard way if you're doing 8th grade, is as the 6th and 7th graders get better at what they're doing, the 8th grade, even with you doing nothing different, moves a lot faster because now they already know the whole gist of what's going on. They know what a progress tracker is. They know what a notice and wonder chart is. They know that they're going to have to come up with a question for the driving question board. So everything else goes quicker the second time through because now those 8th graders did it as a 7th grader. Where the first time through, you had 8th graders that were doing it cold turkey. 6th grade, sorry, every year you're doing it cold turkey, but you get better at that too. You know what they're going to struggle with and what they're not. And until you do it the first time, you just don't know. So you have to have a lot of grace for yourself. You have to be very like calm and know that it gets better. And the first year is going to be what it's going to be. And if you only get through 4 units, you only get through 4 units. And if you're on lesson 4 in October, so be it. Like it's okay, right? You're going to get there. So this will link to the folder that has all of the things that I showed you today. But if you email me, I have a folder of open-sided files to share, which I'm happy to share. In that folder, there are, in that folder, I have a folder for each of the 8th grade units. And in those folders with the 8th grade units, I have folders for each lesson. I keep walking in front of it, that's terrible. And in the folders for each lesson, I have all the things that I use. I have my slides, I have all the handouts, I have the check-in, I have videos of the lessons that I did. There's videos embedded in all of my slides of all of the labs and the lessons and the pictures and all of those things. And I have them all set for anyone with the link can access them. So if you email me, I can share that with you. I don't share that with the QR codes because I don't really want that going out into the world, but I'm happy to share that with anybody here who needs that kind of resource. I have a test here, which I can end with the test. So in Open SciEd, this is their soccer assessment. So Open SciEd assessments, one of the things people complain about the most is they're so open-ended. They're hard to assess. The kids aren't sure what to do because they haven't had an assessment like this before, and they're impossible to grade. So this is the soccer assessment. You can see they're talking about the kinetic energy and which is most likely and least likely to cause a concussion. So that's the idea behind this assessment. And so when you look at their answer key, they're like, well, there's more than one answer that's possible because it depends on what they're thinking. If the ball's moving really fast, then the ball could cause a concussion. But when they take this assessment, they don't know about speed and mass and the differential. So when they take this assessment, they know things that are heavier cause higher peak forces in a collision because they have more kinetic energy. And they know that things that move faster have more kinetic energy and cause higher peak forces in a collision. They know that. But it's after this assessment that they find out that speed increases kinetic energy by the factor squared, where mass is only by the factor. So they don't know that yet when they're doing this assessment. But still, this assessment is kind of hard for them to handle. So what we did in Westfield was we turned it into more of a traditional kind of test. So you can see we have some vocabulary with matching. We have some true and false. We have some multiple choice. And then we get to the soccer portion of the assessment where we're asking which items have kinetic energy, which is the most likely to cause a concussion, which is the least likely to cause a concussion. And so the open-ended part is not the whole thing. So they have kind of a balanced assessment with some more concrete questions and some open-ended questions. And then we have them draw a free body diagram, and we ask them, how prepared do you think you were for this? And so, this is the kind of tests that we give with the Open SciEd part usually factored into it somewhere, so that it's not just that open-ended assessment that is very hard to grade. I don't know if I meant to say something and I missed anything. This is the Open SciEd materials. You guys all know how to find that because I think everybody in here said they were using it. So, I tend to download the whole file. So like here for my drive for 6th grade, like I said, I'm doing 6th grade for the first time in a long time. So I have my Light and Matter. This is the Open SciEd file. So I just download the Open SciEd file and I have it there that I can open up whatever I want and see what I need. But I also have, all the things that I've come up with or that other teachers in our district have come up with who have shared with me because, we try to work together. We're not on an island on our own, thank God, because I can't imagine. But some people, when they come here to talk about it, they're trying to do 2 grades at the same time all alone, and I can't imagine. I can't imagine what that would be like. I constantly feel like drowning, and we have a very supportive department chair who's recording us. So, yeah. But does anybody have any questions? Anything I can answer or share or anything at all? Maybe not. Everyone wants to go home. I don't know. So this slide with this QR code will take you to the folder for all of the conference material. So this slide deck, my paper that has my email address on it, all the files that I shared
and the assessment that you just showed
is in there.
That's awesome. Thank you so much. Well done.
Thank you.
Also, my kids are
It took a long time. It took a long time to get there, but the other file that I shared with all of the links to all of the stuff that I have, you have to email me for that. So you have to email me and say, please share your stuff, and I will add you to the folder. But that's not linked to that because I didn't want that going out into the outside world for. Yep. And if you only have this, that paper is in the folder. And my name is there for the owner of all the files too. So I think you can click on that to see my email as well. Any other questions? I've taught a lot of Open Science. I really like it.
Do you currently only teach one grade level?
No, I have 6 and 8. So I've taught 8. This is probably my 5th year teaching 8th grade. And then this year I have one section of 6th grade. And I haven't taught 6th grade for 3 or 4 years prior. So I never taught the healing unit. We're doing that next. So wish me luck. But
I'm split between. Okay.
so that's really hard because there's so many materials for both 7th and 8th, especially in Unit 1. Like there's so much chemistry.
Yeah, thankfully I have 2 spaces.
Oh, that's good. I'm in a lot of classrooms. I'm in 3 classrooms, so that makes it challenging. I got a little cart, and we go around, but like my tracks are on the cart, and like poor Melissa's there, and I got the tracks in the cart, and go into the other room, and then come back and set up. So it's a lot, but all the units are not like that. The cows unit has much less setup, and the 6th grade, the Hale unit has much less setup. So it depends on the unit you're in, but unfortunately, 7th and 8th grade, Unit 1, both have a lot of stuff. A lot of activity. It's exciting for the kids though, and I like that. And so just like lean in and love it as much as you can is all I can say, because it really does pay off after a few years when they're coming up through the pipe and you're like, wow.
I just wanted to ask, is the fast pace in the 8th grade, is that due to continuity in the 6th, 7th grade?
Yeah, I think there's 2 reasons for it. I think one, as an 8th grader, they expect them to be able to work more productively in a 40-minute class period. So in other words, in 6th grade, you do the notice and wonder, and they will literally spend 20 minutes sharing their notices and wonders if you let them, right? So it's like, I saw that it was reflective. I saw that it was reflective. I saw that it was reflective, right? So like that doesn't happen in 8th grade, right? So in 8th grade, the sharing of the notice and wonders might be 3 minutes instead of 10 minutes, right? When you're coming up with driving question board questions, they're ready to go. They're ready to share their related phenomenon. When you do a lab, the instructions are as opposed to, right, like this. So I think it's all just about the maturity of the student and being familiar with the way the curriculum rolls out. So the combination of the 2 makes it a higher level academically and quicker paced. So if you try units in 6th grade and they say here it's going to be 28 days, you're probably talking 52 days because you can't go that fast in 6th grade. They can't work that quickly. They can't make transitions the way the 8th graders make transitions, and it's all new. So you have to teach them how to do everything. You have to teach them how to like notice and wonder. What does it mean to notice and wonder? Like, and they think a wonder is a notice, and they start asking questions like, no, did we see that? Nope, it goes over here. Inferences, right? That's something we had to teach 6th graders. It's about inferences versus observations, right? But you don't have to teach the 8th graders that. If they make an inference, you can point out to them, is that an inference or an observation? And they'll be like, oh, that's like they know the difference between the 2 because they've done this so many times. But I wouldn't put an 8th grade unit into 6th grade without a lot of editing to pare it down because they're not going to be able to keep up with the pace. And the same the other way. If you're teaching a 6th grade unit in 8th grade, you got to speed it up because they'll get very bored otherwise. Any other questions?
Thank you.
You're welcome. Send me an email and I can share my folder.
How come you're not doing thermal energy next? How come you're doing healing next?
Oh, so we found, I don't know, I think they didn't like healing at the end because they didn't have enough time. And they felt like they'd run out. And so by putting healing second, they get to spend the time. And then they run out on the tsunami unit. And who cares about tsunamis?